So I wanted to start off this course discussing the foundations of what makes a vector database a vector database, and that's the vectors. A vector database without good vectors is just a regular database, a place to store data. And so when we talk about vectors in regards to a vector database, they're usually referred to as embeddings. And so embeddings are vectors. You can think of them in the same way that you would think of a regular vector. And so that embeddings, they're vectors that represent complex data like text, images, or audio in a numerical format, because vector databases are used in machine learning applications, and we need to first be able to take this unstructured data like a text or an image and then put it into a numerical format that can then be fed into a machine learning model or used in some sort of application. So for example, these vectors over here, this is commonly how you would see a vector represented in your matrix or linear algebra class. These have coordinates, like this one has coordinates 2 and 3, and then this one has coordinates 5 and 2. And in a vector database, this is how your text, images, or audio would be stored as these vectors with numbers here. These vectors, these embeddings, they capture semantic or structural relationships between data points. So an embedding, this numerical representation here of a particular piece of text or an image or an audio, is going to represent in a numerical format the meaning of that text, what it's about, what it's talking about, who it's talking about, etc. As well as the image. If it's an embedding of an image, it's gonna this numerical vector right here. These numbers are gonna represent, what's the image about, what's the meaning of the image, anything that a human being would think of or represent if they looked at it or read the text or the image. And so, like I said, embeddings are used in machine learning tasks to enable us to do things like similarity search, right? So, if we want to find out which news articles are similar to a particular news article that a user is reading, so we can recommend those news articles, we're going to use a vector database for that. Classification or clustering, since we already have like text, images, or audio, whatever our data is in this assumed to be high quality numerical format like these vectors here, then we can start clustering them to see which articles or which data points are similar to each other. We can start running classification tasks on them. We can also now take this vector database and what's been used commonly in modern day times, and we can use it for retrieval augmented generation. So whenever you're talking to ChatGPT or any other chatbot that's ran by an LLM, if that LLM needs to retrieve any relevant data related to your message that you sent it in order for it to respond, it can now do that with the help of vector databases. And I'm going to show you what that's like and how that's done later on in the course. And so again, we have these embeddings here. They're two-dimensional embeddings, two-dimensional vectors. In the real world, these embeddings are very high dimensions relative to 2 or 3D. We're talking 384 dimensions, 1024, or even higher, 1500, or even higher than that, sometimes 3000. And so they're high dimensional representations. They're very high dimensional vectors because they have to capture a lot of meaning around the object that is being vectorized or turned embedded. So, for example, articles can mean a lot. There can be a lot in an article, and so we want to have a lot of dimensions to be able to capture all that complexity and all that meaning. And so again, this is what we're going to be working with. This is the bedrock. This is the foundation of a vector database. And so we're going to spend the first half of this course really understanding embeddings before we head into any sort of exercises with vector databases.